Hello, my name's Rasmus Hulthe. I'm a student at the Chalmers University of Technology in Sweden, Gothenburg. I'm also the coach for my university's ICPC team, so we've never made it to World's Finals. And I'm going to talk a bit about the uses of the problem format, especially the new version that Fredrik mentioned earlier. Whoa. Okay, I have animations, cool. So let's begin from the beginning. What is the problem format? Well, to go from the concept of what a problem is to actually implementing the problem, to having the problem in a competition in an interactable way, you need to be able to systematically define what the problem is. This is what the problem format helps you do. And another big benefit is that since many systems support it, say Catis, DomJudge, PC2, and many community-developed tools, it is very easy to standardize integration between systems. If you were here during the talk by John, I think 2 days ago, where he talked about shadowing, that would be very, very difficult if there was not a standardized integration, a way to have the same problem on multiple contest systems. So having one format is very, very useful. So I'm going to be going over some changes. As you can see, there's quite a lot of changes, and I would argue not everything is fully listed, and many of the bullet points are very, very complex, and we could talk about them for many, many hours. So I've limited myself to mostly talk about the 3 points you see there: multipass, static validators, and submit answer. Because I feel like these deserve some extra time. And I'll also give a brief overview of some changes that I would like to talk even longer about, but that I only had a little bit of time to talk about. So let's start with a general overview. Statements can now be written in Markdown. Previously, they could only be written in LaTeX, and the addition of Markdown is very nice. You can also have write-ups for each problem now. How these write-ups will be displayed is up to each individual contest system, but an example could be that when the contest ends, a PDF is released in the attachments, and you can just download it and read. This is especially useful if there's no presentation, like presentation showcase, because then each user can just read the editorial. Another nice feature is that you can now configure what programming languages a specific problem can be solved in, what you can submit in. Say you want to host a PHP-only contest. The one guy can now do that. Or maybe you just don't want to allow Java. Another thing is that you can now explicitly define the time limits. For some of you, this means something. If it doesn't, you probably will never notice, but it's a nice feature. Custom graders are now completely removed. It's a little similar to the last point. If you don't know what this means, you don't have to care about it, but it's a good thing. And if you're panicking in the audience, come talk to us after. Probably you don't need a custom grader. And if you actually really do, are you sure you do? And if you actually really do, you can kind of still do it hackily, but you shouldn't. And then we have a better structure for problem solutions. So like Joshua talked about earlier, it's good to have many, many judge solutions. And having many solutions is great, but it can become a little cluttered if you just have them all in one place. So this better structure allows you to organize them. And when running tools like problem tools and BAPSE tools, you can now actually get feedback if they're doing what they're supposed to do to your many, many, many test cases, like Joshua talked about. There's also many more ways to credit problem developers. Previously, it was kind of like if you were an author, you'd get credit, but if you like translated a problem or just helped out a little bit, it's like a little iffy. So now there's many more ways. You can, for example, be a translator or just a general acknowledgements. And then we have visualizers. I wish I could talk a little more about visualizers. They're probably not the most useful things, especially in competitions like ICPC, but they're kind of cool. Say you have a problem which tells you to find the shortest path in a maze, but you're getting the wrong answer. A visualizer could help you visualize your output and compare it to the solution. And then you'd see, oh, I'm taking a longer path. Oh, I'm going this weird route. And then you could debug more easily. This is most useful in teaching, maybe, and beginner contests, where it's good to give hints, maybe not in the world finals. And then we have changes to output validators. An output validator is a program that takes your submission output and judges it. It looks at the output, and usually it compares it to a judged solution's output. It's responsible to give a verdict, like AC or wrong answer, and to give some feedback. These must now be written in either C++ or Python 3, and the default has been improved. So for more problems, hopefully you won't need a custom output validator, but there's still many cases where you do. Now with all this information, we can move on to the big three. So we start with multipass. Multipass runs similarly to a normal problem at first. You have your submission, it takes in output and produces an output. The output validator looks at the output, but instead of just giving a verdict like earlier, it can now decide that, no, we should actually run your program again and create a new input. It creates a new test case to run your submission on. And it continues this loop until it decides that it has a verdict for your submission. These multiple passes or multiple runs are now ran in completely separate sandboxes. So you can't cheese it anymore. Previously, you could kind of hack a multipass problem together, but now they're way more structured. So what is the actual use of a multipass problem? An example multipass problem would be a simple communications problem. I'd say this is the most classic, an encrypt and decrypt program. So you're tasked with writing a program that can act as two different people. In this case, we have Bob. He wants to send a message to Alice, and he gets to add some extra information because when he sends it, some of the bits might get flipped in transit. And it's also supposed to be able to act as Alice, receiving this message with some extra information that you've decided, but some of the bits are flipped, and it's your task to decode what the original message was. A simple solution could be that you duplicate a lot of the information, but of course we can have way more interesting problems. One such interesting problem is Flight to the Ford from BOI 2022, day 2. It's very interesting, and it's a multipass problem as well as an interactive problem. A little similarly like before, you're developing a messaging system. You're supposed to be able to send and receive messages. But instead of sending, getting a whole message you want to send, encoding it and then sending it off, you're now sending one bit at a time. So you send a bit and you get feedback instantly if the bit sent without flipping or if it flipped. And it's guaranteed that no 2 bits will flip in a row. So you can adapt your sending strategy to adopt on the fly, which makes for a very interesting problem. And for those curious and want to think about it a little bit coming up, you're supposed to send a number up to 10 to the power of 9. But we don't have time to actually go through and solve this problem right now, because that would take way more time than I have, and I'm already going to be short on time, I think. So let's move on to the next big feature that I think is very interesting, which is static validators. A static validator is somewhat similar to an output validator, but instead of validating on, well, the output, it validates on the static source code. So some things that is that's possible now is code golf. It checks how long the code is, counting the number of characters, and can either give you AC or a wrong answer. It could, for example, only accept solutions below 200 characters. They can also be used in conjunction with an output validator, which would make sense. So say you have a problem where if you have a correct solution, you get more and more points based on how short it is. Just a quick note, source code parsing is very complex. I'll touch a little bit more on that later. But just while you're hearing all of this, it can be a good idea to use with a little bit of caution. Because it's very complex, we think it's going to be mostly useful within academia, where perfect competitiveness is not required. It's mostly good to just deter the students from using unintended ways. So one such problem that would be very useful within academia is a lot of teachers try to teach recursion by using the Fibonacci problem. I think the Fibonacci problem should be solved using iteration and not with recursion. So they give this problem. Print the whole Fibonacci sequence in order up to 10 to the power of 5. But you're not allowed to use for and while loops because you're supposed to use recursion. And before, this was a very tedious process. Maybe the teachers could read through the code and check, do they use a for loop here? But now you could use a static validator to just wrong answer any solution that uses the keywords for or while. It's not a perfect solution, and it definitely has workarounds, but it's similarly to a lock on your door. If someone really wants to get in, they can always break the window, but it'll deter 99%. Similarly, a student, if they realize, oh, my solution just got wrong answered because it says I used a for loop, well, maybe I should just do the assignment. A more funny problem is what I call the pilint problem. So you're tasked with a very, very simple problem. Check if an integer is prime, and the limit could be very small. And if your solution is valid, if it can check if an integer is prime, your score becomes the pilint score of your source code. So for those of you who are not aware, pilint is a source code checker that gives you a score based on how well you follow standards of programming. So if we look on the one on the left, it's very compact. It doesn't use a lot of new lines. It's it has a random try except at the end. Why is that there? And you can see the output from pilint. It's a long list of you shouldn't have multiple statements on a single line. And it only gives a 3.3 out of 10, which would be a 33 points. And in the middle we have a somewhat normal code. Maybe this is what I'd write, just a quick check. But it still only gets 75% of the points because it doesn't have doc strings. And what competitive programmer has ever heard about a doc string? And then on the right we have a 100-point solution, which has random doc strings for your competitive programming solution. This also wouldn't be very useful in the ICPC finals, but maybe you could have it as an April Fool's problem. So a final little word of caution. It can be very tempting to use static validation everywhere to forbid unintended solutions. Say you want to forbid the use of treeps, or maybe you want to forbid like any whatever. It can be very hard to parse the data structure. Like someone can write it in a very weird way, and your parsing could miss it. And it's especially hard in contests supporting many languages. Say if you use Catis and just have every language allowed, then it would be very, very difficult to write a parser for both PHP, Java, maybe even Haskell. Like, it's very hard to parse for every language because it's hard to even parse for one. So use it, but use it with caution. And then we're moving on to the final one, submit answer. Submit answer, some of you can probably already guess from the name what it is. You're submitting an answer, not the code. This is similarly to how Advent of Code or Euler's project does it. You just get a big test case to verify that you have a solution, but they don't actually intend on running your code. So instead you prove it by giving the answer. This is very beginner friendly because they can play around with it. They don't have to learn how the judge operates. They just kind of have to know how to run a program. They don't have to know exactly how to take input. They can even hard code the input if they want. It makes it very easy and nice for them to play with. And I think this is going to be a big development in hosting really beginner-friendly contests. Of course, it's also very low server load, which is good if you have a really, really big contest and you want a very small grading time. It grades very fast. So instead of having like a 10-second time limit and like hundreds of thousand people submitting, you could have a submit answer and it would judge in like a millisecond. No, but like 100 milliseconds maybe. This could also be possible to host AI competitions, a little like Kaggle. You could get a big data set and train a model offline and then submit your predictions. It's very versatile. Of course, it's not perfect since everyone will have different hardware, so it could be very unfair, but especially beginner friendly, and it's very versatile. So to wrap it up, the new format is almost finished. The specification is released. The final details are still being finalized, but we're basically there. And why would anyone want to adopt it? Well, as you've seen, you can make many, many cool problems, and especially a lot of funny problems. I'm looking forward to seeing even cooler April Fool's problems. The previous presenter, Joshua, always holds a nice competition. I'm excited. And I didn't have a lot of time to get into it, but it also way simplifies the implementation process of problems and makes it very nice and more correct. It's harder to make mistakes now. As you saw, like custom graders got removed and a lot of the defaults have been improved to just help the process, make it more streamlined. And if you have any more questions, you can always reach me on my email. And if you have any questions right now, I'm happy to answer.
Yeah, I'm intrigued by the submit answer extension. Would it also be possible to, like Advent of Code, that different users will have to submit a different answer to the same problem?
I don't think that would be possible right now. I think it would be one test case, but in theory, that could be made. I don't think it's really been considered too much, having different test cases for different users in a submit answer problem. It's not something that's been thought about a lot, I think, but if that was a big thing people wanted, it could probably be done. But as of now, it's not possible.
Yeah, I think a very interesting talk. Thank you so much, Rasmus. I actually had the time to look at the slide prior, so I was taking a coffee break. But the real question I have is on this one. You talked about problem package being finished. First of all, well, it's not shocking to anyone here in this audience, but will you actually ever finish, or is it really a start for a new beginning? Right? You finish one, and then you iterate and make it better. But do you have a cadence as to each iteration, how long it's going to take? Is there a regular schedule for it, or is it just one-time thing, won't do anything for quite a while, and then next one, etc.?
Yeah, I think it's been continually worked on since 2002 or something. It's very, very old. And really, it's only been one version so far. It's kind of sprung off into small subversions, but mainly it's been like the old version. And now this big release is like the new version. So it's only really been two versions, and of course there's been additions on the way, and it's been continually worked on. And this new version has been mainly worked on over the last 3 years, I think, and is being released this month. Yeah, it's going to be very exciting. Any other questions?
Yeah, when will the implementation will be finished?
You have to ask your local contest system for that one.
Yeah, I see. Thank you.
He asked if when will the implementation be finished for each contest system, and yeah, it's a little funny because he's helping develop.